Hey everyone, welcome to today's video, and in this video we are going to solve this wonderful equation and then calculate the value of a. Now as you know that whenever number is not carrying any power, so that means by default its power to be taken as 1. So I'll put the power 1 on every single k right here. After this, what I'm going to do is I'm going to use a property of exponents which says that a raised to the power m multiplied by a raised to the power n can be written as a raised to the power m plus n, which means if the bases are same, the powers can be added. So I'll add all these powers here and let us see what happens. So k raised to the power 1 plus 1 plus 1 minus k raised to the power 1 plus 1 is equal to 48. So this now means that the value of k raised to the power 3 minus k raised to the power 2 is equal to 48. Now if you try to solve this using a conventional cubic rule, then this would be a very lengthy process. So instead of that, what we are going to do is first of all shift 48 onto this side. So this is minus 48 is equal to 0. And after this, what I'm going to do is I'm going to bifurcate this 48 in a difference of two numbers. So this is k cube minus k square minus 64 plus 16 is equal to 0. Now after this, what we are going to do is, if you notice, this is the cube of 4 and this is the square of 4. So I'll write this as k cube minus k square minus 4 raised to the power 3 plus 4 raised to the power 2 is equal to 0. Now let us rearrange this. So this is k cube minus of 4 raised to the power 3 minus taken as common. So this is k square minus 4 square is equal to 0. Now after this, what we are going to do is use the identity of a cube minus b cube, which is a minus b multiplied by a square minus ab plus b square. So this would be used in the first bracket over here. And in this, the algebraic identity that we'll be using is a square minus b square, which is a minus b multiplied by a plus b. Now let us use that. So this is k minus 4 multiplied by k square minus 4k plus k square minus 4k plus 4 square, which is 16, and then minus k minus 4 multiplied by k plus 4 is equal to 0. Now from this entire equation, if you notice, we can take out k minus 4 as common. So thereby the first bracket would have k square minus 4k plus 16 minus of k minus of 4 is equal to 0. So the value of k minus 4 will then be k square minus 5k plus 12 is equal to 0. So if you see, the product of two brackets here is 0, which means the value of k minus 4 is equal to 0, which gives us the value of k as 4 for the first part of the equation. And the second one, we have k square minus 5k plus 12 is equal to 0. Now to solve this quadratic equation, we will be using the quadratic formula, that is k is equal to minus b plus minus square root of b square minus 4ac, and then this entire equation is divided by 2. So right here we have k is equal to plus 5 plus minus square root of 25 minus 48 divided by 2. And then when you solve this, you get this different answer. So now the answer that you get is minus 3 plus minus iota square root of 39 divided by 2. So I hope that this question was informative enough, and for more such videos, don't forget to subscribe to our YouTube channel. Thank you so much for watching.